In this video, I'm going to talk about computational thinking concepts and powerful ideas. Computational thinking concepts are the concepts programmers engage with as they program. Powerful ideas are the skills within a domain that change how we think and problem solve. The powerful ideas that operationalize computational thinking are also the computational practices that programmers develop when they engage with the computational concepts. For almost all concepts and powerful ideas, I'll use code.org examples to show you what they mean. Before we dive into computational thinking concepts and powerful ideas, I'll review several terms that I will use in this video. You will frequently use or hear them when you teach computational thinking. First, computational thinking. It is the mental skill to apply fundamental concepts and reasoning derived from computing and computer science to solve problems in all areas. Algorithm, a list of steps to finish a task. The steps or instructions can be carried out by a human or computer. Program, an algorithm that has been coded into something that can be run by a machine. When your students work on unplugged activities, the activities that are used to teach coding without computers, they will create a list of steps to solve a problem. This list of steps can be called algorithm, but they are not a program. Programming, the art of creating a program. Computational thinking concepts. These concepts are the concepts programmers engage with as they program. There are 4 concepts that students will use very often when they do code.org coding. These are sequence, loops, events, and conditions. Sequence. A key concept in programming is that a particular activity or task is expressed as a series of individual steps or instructions that can be executed by the computer. Like a recipe, a sequence of programming instructions specifies the behavior or action that should be produced. For example, the bird can be programmed to move forward, turn left, and then move forward to get to the pig with the sequence of steps shown on the right. The second concept is loops. Loops are a mechanism for running the same sequence multiple times. For example, if the bird wants to move to the pig, it has to go 3 steps forward. Instead of using 3 move forward blocks, we can use 1 move forward block in a loop. For loops, we need to define the number of iterations. In this case, the move forward block should be repeated 3 times. The third concept is events. Events are something that happens that causes something else to happen. Events can make interactive media. This program shows that when the hamburger is clicked, it will say hello world. When the fries are clicked, they will say bye. Another key concept in interactive media is conditionals. Statements that only run under certain conditions. Common conditionals include if, when, and while. This program shows that if the character stands on a blue coral, it will turn right. Powerful ideas. Powerful ideas are the skills within a domain that change how we think or perceive the world and problem solve. The powerful ideas that operationalize computational thinking are also the computational practices that programs develop when they engage with the computational thinking concepts. The powerful ideas students will use when they work on code.org lessons are decomposition, pattern recognition, algorithm, and debugging. Decomposition is the process of breaking a larger problem into smaller sub-problems. The divided parts are not random pieces, but functional elements that collectively comprise the whole system. For example, how can the bird get to the pig? The bird needs to move forward, turn left, and then move forward. Let's focus on the first smaller task, move forward. First of all, let's figure out how far forward does the bird have to walk before it turns. One step forward, right? So here we break the problem into three smaller ones. Move forward, turn left, and then move forward. And we have figured out that the bird needs to move one step forward before it turns left. Next smaller task, just turn left. Next, the bird has to move forward again. How many steps? 2 steps. Okay, we solved all the smaller problems. We'll then put the pieces together. Here is the program. Pattern recognition. Pattern recognition means identifying patterns underlying the information structure. How can the bird get to the pig? The bird needs to move forward, turn right, and then move forward. How many steps forward? 4 steps. So we will have 4 move forward blocks. After the bird turns right, how far forward does it need to move? 4 steps. So another 4 move forward blocks. There seems to be a pattern. What is the pattern? First of all, there are 4 move forward blocks before the bird turns. We can have 1 move forward block enclosed by the repeat block. That's a loop. So 1 move forward block repeated 4 times. After the bird turns right, there's another pattern. Again, 4 move forward blocks. So again, we can have 1 move forward block repeated 4 times. Algorithm. An algorithm is a list of steps to finish a task, a list of logical instructions to solve a problem. The instructions can be carried out by a human or computer. Debugging. Bug is part of a program that does not work correctly. Debugging means fixing problems in an algorithm or program. To recap, these are the computational thinking concepts and powerful ideas we reviewed in this video. Computational thinking concepts include sequence, loops, events, and conditionals. Powerful ideas include decomposition, pattern recognition, algorithm, and debugging.